Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 2 in the directory traversal module titled File Path Traversal, Traversal Sequences Blocked with Absolute Path Bypass. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path, go down again, select directory traversal, and then go down one last time to lab number 2, titled File Path Traversal, Traversal Sequences Blocked with Absolute Path Bypass. Alright, let's get started. This lab contains a file path traversal vulnerability in the display of product images. The application blocks traversal sequences but treats the supplied file name as being relative to a default working directory. To solve the lab, retrieve the contents of the etc passwd file. Okay, so our target goal over here is to exploit the path traversal vulnerability, which has some kind of defense on it, and then retrieve the contents of the passwd file. All right, let's get started. And notice over here, this is the built-in browser in Burp, and so all my requests are already going in my Burp proxy. Okay, while the application is loading, you could see over here that it's retrieving images from a certain directory in the backend server that is hosting the application. And so this for sure needs to be tested for LFI, RFI, and path traversal vulnerabilities. So what I'm going to do is I'm going to send this to repeater and look at the request. So if we hit send right over here, you could see that this is a 200 OK message, and this is the content of the 45.jpg image. So what we're going to do is we're going to try what we did in the first lab, which is ... so that we could get out of the directory that we're in and move to the root directory, and then attempt to access that etc passwd file and hit send. Okay, that didn't work. We get a 400 bad request and it says no such file on the system. All right, the next thing that we're going to try is see if the application maybe filters on this sequence right over here, but the developers forgot that we could just request the absolute path of the file that we want. So hit send. And here we go. We get the contents of the passwd file. And if we reload this right over here, you should be able to see the congratulations, you solved the lab exercise, which we do. All right, so we were able to manually exploit this vulnerability by just putting in the absolute path of the file that we wanted to retrieve. Now let's script the exploit in Python. So just like the first lab, this should be relatively simple because this is an unauthenticated vulnerability and requires only one request. So the first thing that we're going to do is we're going to import all the libraries that we need. So the sys library, the request library, the URL lib3 library, and then we're going to disable insecure request warnings. So disable warnings, URL lib3 dot exceptions insecure request warning, and then we're going to set our proxy setting because we want all the requests that are made by this script to be sent to Burp just in case we need to view them and debug them if the script doesn't work properly. So 127.0.0.1 port 8080, and again all the HTTPS traffic should be sent to the same place, so HTTP 127.0.0.1 and on port 8080. Okay, this looks good. Next, let's define our main method. So if name is equal to main, then call the main method, and we'll define the main method right over here. In the main method, we're going to check if the user ran the program correctly. So if the length of the command line arguments is not equal to 2, then the user ran it incorrectly. So what we're going to do is we're going to print the usage instructions, which is the name of the program, and then the URL, and we take the name of the program from the command line argument. And then we're also going to print the example instructions, which is the name of the program, and an example URL. So let's say www.example.com. And again, we take the name of the program from the command line argument, and we exit the program. All right, so we enter this if clause if the user runs the script incorrectly. Now let's assume the user ran it correctly. The first thing that we're going to do is create a variable called URL and set it to the second command line argument. And then we're going to print a statement saying that we're exploiting the directory traversal vulnerability. And then we're going to do that using a function that we create called directory traversal exploit, and it takes in the URL. All right, this looks good. Now let's define our custom function that exploits a vulnerability. So def directory traversal exploit, and it takes in the URL. What we need to first set is the URL or the path to the vulnerable functionality. So we're going to name that image URL because it is the image functionality that is vulnerable. And then that's going to be equal to the URL that is given in the command line arguments. So the main URL of the application plus this path right over here, which is the path to our exploit. Next, it's as simple as performing the request. So R is equal to request.get, and we said get because it is a get method over here. That takes in the image URL that we just set. So image URL, we're going to set verify to false because we don't want to verify TLS certificates, and proxies to be equal to proxies so that the request gets sent to burp. And then I want a way to verify that my exploit did work. So I'm going to say if a certain string, which is this string right over here, this user will always be on the system because that's the privileged user or the root user on the system. So if this string is in the response of the request that I just made, that means my exploit passed. So I'm going to print exploit successful. And then I'm also going to print the following is the content of the passwd file. Say file. And then I'm just going to dump the response of the request or the exploit that I just performed, which is r.text. So what that's going to do is dump this right over here, which is the content of the passwd file. All right, this looks good. Now this is if I find this string over here and my exploit is successful. If I don't find this string, that means the exploit was not successful. And so I'm going to print exploit failed. And then I'm going to exit the program because my exploit failed. All right, let's save this and review it. So the first thing we do is check if the script is run correctly. If it is, it calls this function over here with the main URL of the application. In the function, all it does is perform this request to exploit the path traversal vulnerability and dump the content of the passwd file. Let's run the program to see if we have any errors. So terminal, new terminal. And then we're going to say Python 3 directory traversal lab 02 .py, and then the URL of the application. It likely timed out, so let's check, and it did. So let's open another instance of it. Okay, let's copy that, put it in here, and remove the trailing slash because that will interfere with our script. And let's run it. All right, so we get congratulations, you solved the lab, and you could see over here, it says the exploit was successful, and then it dumps the content of the passwd file. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of path traversal vulnerabilities.